Hi everybody, my name is Kylie Mehmet and I wrote my paper on evolutionary changes of the human body, so that's what I'm going to be presenting to you guys today. So my thesis for this paper excuse me, was that the most apparent evolutionary changes in the human body to arise are the transition from quadrupedalism to bipedalism, which may be due to an evolutionary effort to conserve oxygen, the gracilization of bone structure that can most likely be attributed to a progressively sedentary lifestyle, and a change in the timing of molar emergence, which allows for more adequate life histories to be obtained. So, quadrupeds versus bipeds. Quadrupedalism is walking on all fours, while bipedalism is walking on two legs. This shift from walking on four legs to walking on two legs was one of the first major evolutionary changes to occur, and it may have occurred to encourage oxygen conservation. So how do we know when early humans became bipedal? There are multiple anthropological finds, such as Lucy and the Taung child. The Taung child was discovered by Raymond Dart in 1924. This child had a more anterior and inferior foramen magnum, which indicated it carried its head more erect than its predecessors. Essentially, the Taung child was an ape-like hominid that first demonstrated bipedalism. Lucy was another child to be found in an anthropological dig, and she presented with an almost complete Australopithecine skeleton. And Australopithecines were kind of the link between apes and the earliest human forms. And she possessed bipedal anatomy, which included a thicker pelvis and more acute quadriceps angle. And the quadriceps angle is the angle of your femur in relation to your pelvis. So what changes had to occur for bipedalism to be possible? The foramen magnum needed to become more inferior and anterior. There needed to be an increase in the quadriceps angle. The pelvis needed to become thicker. There needed to be a change in the foot shape. Shorter femur, tibia, and fibula needed to occur. Your ischia, which is a part of your hip, needed to become more anterior. And your gluteus medius and minimus needed to become hip abductors rather than hip extensors. And all of these changes did occur, which is why we are bipedal today. So in a study performed by Herman Poncer, David Rocklin, and Michael Sokol at the University of Arizona, they measured oxygen consumption and output in chimpanzees and humans. And they put 5 chimpanzees on a treadmill and had them perform both gaits, quadrupedalism and bipedalism. And then they measured their oxygen output. And then they put 4 humans on a treadmill and measured their oxygen output and compared the two. And in the results of this study, they found that chimpanzees use 75% more oxygen in each trial than humans. And this shows that bipedalism is more efficient in humans, but not in chimpanzees because they do not possess the evolutionary changes that make it more efficient. And those evolutionary changes are the things we just talked about, such as a change in the foot shape, an increase in quadriceps angle, and a change in the position of the foramen magnum, etc. So the next evolutionary change in humans I want to look at is gracilization, which is a decrease in strength and bone density. And it is most likely attributed to an increasingly sedentary lifestyle. Excuse me. So in an observational study, living human participants were given a CT scan and a microtomography scan to measure bone density along their limb epiphyses. And fossilized remains of early humans were also examined, and their bone densities were measured, and then those two numbers were compared. And the researchers found that there is a direct relationship between bone density and a sedentary lifestyle. And they found this by looking at the age of the bones and societal norms of the time. So when they examined fossilized remains or older bones, they dated those and then looked at what was going on at the time. And they found that the younger the bones became, the more sedentary society was at that time. And this change to a more sedentary lifestyle can be attributed to a couple of reasons. Early humans had to chase prey down for food. And so they were much more active in that aspect. And as technological advances took place, humans became more sedentary. And some of these technological advances are the invention of modern weapons, such as bows and arrows or guns, and domestication of animals, such as horses. This decrease in trabecular bone density also brought new opportunities for diseases. One of these is osteoporosis, and that led to an even further decline in bone density. So this decrease can be kind of a cycle. And the last human evolutionary change I want to look at is molar emergence. And so there's a correlation between eruption of the first molar and brain size. And it's been hypothesized that this correlation is due to solid food consumption preceding weaning and molars erupting to provide more efficient mastication. So essentially, modern humans, and even early humans compared to apes, were being weaned later and eating solid food earlier, so they needed their molars so they could chew that solid food better. So in primates, molar eruption occurs at weaning when 90 to 95% of brain growth is complete. In humans, weaning, complete brain growth, and molar eruption occur much, much later. And fossil evidence shows us that early human molar eruption occurred later than non-human primates, but like monkeys or chimpanzees, apes, but 2 to 3 years earlier than modern humans. So the last thing I want to look at is early and modern human relatedness. And only a quarter of the traits shared by Australopithecines and modern humans can be considered synaptomorphic. And some of these traits include some facial features, post-canine dental reduction, and formation of the pelvis. And this number, only a quarter of traits, is really low. So this lack of shared derived traits can be attributed to genetic drift and vicariance. So in conclusion, evolution has allowed for bipedalism, a decrease in trabecular bone density, and a later emergence of molars to occur in modern humans. There are many variable theories for why these evolutionary changes have occurred, but the most relevant maintain that bipedalism began to occur in humans to allow for conservation of oxygen and an overall increase in efficiency to allow for survival as the Earth evolved. And that the recent decrease in trabecular bone density occurred due to an increasingly immobile society. And to this conclusion, I don't have it written in, but I do want to add that, that there is a direct correlation between brain size and molar eruption. As it increases, molar eruption occurs later. So that is my presentation. I hope that you guys enjoyed it and hopefully learned something. So thank you so much.